French Polynesia faces an existential geography problem. Every year, rising sea levels are steadily swallowing the coastlines that these island communities depend on. At the same time, the local environment is struggling under a second, man-made threat. The region's pearl farming industry alone generates roughly 1,200 tons of synthetic waste every single year. Instead of degrading, heavy nylon nets and rigid plastic buoys wash ashore, embedding themselves deep into the sand and contaminating the fragile lagoon ecosystems. This leaves isolated communities with a surplus of the very material they lack the facilities to manage, creating a situation where the pollution and the rising tides are part of the same crisis. When most countries want to hold back the ocean, they rely on standard civil engineering, massive coastal dikes built from reinforced concrete and steel. But building those structures on a remote Pacific atoll is logistically impossible. Moving heavy materials across the vast ocean is prohibitively expensive, and the islands do not have the specialized cranes required to install them. Furthermore, traditional cement manufacturing has a high carbon footprint. Releasing massive amounts of CO2 to build a defense against climate change only serves to accelerate the global crisis. Even standard ocean cleanup efforts reach a dead end here. They pull the plastic out of the water, but without local processing, the waste is simply gathered and stored or shipped away at great cost. This highlights the ultimate core economic roadblock. Isolated nations need massive climate defense infrastructure to survive, but they lack the heavy industry and the tax base to pay for traditional construction. Uses cold compression to press exactly 100 kilograms of raw plastic into 1 square meter of barrier block. Adding a binder achieves a 500 kilogram per cubic meter density. Because the blocks are manageable without heavy equipment, the system removes the need for construction cranes, wet mortar, or steel reinforcing rods. Instead, the material is manufactured into 7 patented geometric shapes. Local residents can carry and assemble these self-locking pieces by hand, snapping them together to build their own seawalls, exactly like a modular set. The island's most abundant environmental liability becomes a zero-emission, community-built tool for civil protection. If the local government isn't paying for this infrastructure, someone still has to buy the mechanical presses and cover the operational costs. Cleanbrick Europe's business model strictly revolves around licensing intellectual property and supplying patented steel molds. Capital flows through sponsors across 4 sectors. Luxury eco-resorts finance licensing to protect pristine beaches and overwater villas. Pearl and beverage distributors pay to eradicate thousands of tons of their plastic waste. Finally, international airlines co-finance to secure vital environmental carbon credits. By aligning the financial interests of these sectors, a public defense system is generated entirely through private capital, requiring zero public debt. Tahiti serves as a prestigious pilot project. Once validated by top-tier luxury brands, the goal is to trigger a domino effect across other vulnerable island territories. The entire financial blueprint used in Tahiti can be replicated in any geography where a high-value tourism economy is threatened by coastal erosion. Environmental impact scales when engineering is paired with an economic model that transforms corporate incentives into local infrastructure. By turning waste into a resource for survival, the community gains a defense that the market, rather than the public, pays to build.
Cleanbrick Tahiti, an inspiration for a better world.